Welcome to Section 2, Lesson 5. So far, we have worked with algebraic expressions that were already written in symbols. Today, we cover the inverse skill, the one that turns word problems into solvable algebra, translating an English sentence into an algebraic expression or equation. This is the bridge between everyday problem statements and the symbolic machinery you have been building, and it is by far the highest leverage soft skill in the entire algebra course. Most students who struggle with word problems do not struggle with the algebra itself, they struggle with the translation step that comes before any algebra can begin. Today we fixed it by learning the keyword dictionary, the word order rules, and a small library of templates you can apply on autopilot. First idea on the board. Translation is a two-part skill. Part 1 is keyword recognition. Every English math word maps to exactly one arithmetic operation, and you need to know the dictionary code. Part 2 is word order reading. Some operations care about the order of the inputs, and some do not, and English sentences sometimes flip the natural mathematical order. Get both halves right, and any reasonable word problem can be turned into clean algebra in under a minute. Get either half wrong, and the algebra you write down will not match the problem you were given. Second idea. The keyword dictionary has roughly 15 entries that cover 90% of all algebra word problems you will ever see. The sum, plus, more than, increased by, and added to all map to addition. The difference, minus, less than, decreased by, and subtracted from all map to subtraction. The product, times, twice, doubled, and tripled all map to multiplication. The quotient, divided by, per, and ratio all map to division. The word is equals, gives, yields, and results in all map to the equals sign. Memorize this short list and recognition becomes automatic the moment you read a problem. Third idea. Some words flip the input order in surprising ways. The phrase 5 less than a number translates as the variable minus 5, not 5 minus the variable, because less than reverses the order. The phrase a number subtracted from 10 translates as 10 minus the variable, not the variable minus 10 for the same reason. The phrases more than and added to also tend to reverse. Always read your translated expression aloud and check it against the original sentence to catch order flips before they become wrong answers. The order checks take 5 seconds and prevent the single most common translation error in beginning algebra. Today we will lock in the dictionary, work two full word problem translations together, and call out the 4 most common pitfalls. Translation is the conversion of an English sentence describing a numerical relationship into an algebraic expression or equation that captures exactly the same relationship in symbols. The skill rests on 2 pillars: recognizing the keywords that name each arithmetic operation, and reading the word order carefully so the operands appear in the correct positions on either side of the operator. Here is the keyword dictionary. Plus, sum, more than, increased by, added to all mean addition, minus, difference, less than, decreased by, subtracted from all mean subtraction, times, product, twice, doubled, tripled all mean multiplication, divided by, quotient, per ratio all mean division, is equals, gives, yields, results in all mean the equals sign. Memorize the dictionary so the recognition is automatic the moment you read a problem. Step 1 in the workflow. Read the sentence carefully and identify the unknown quantity that needs a variable name. Most word problems use a number, an amount, an age, or a count, and that quantity becomes the variable, usually x or n. Write the variable assignment down explicitly before you begin translating, so the rest of the work has a clear anchor. Step 2. Scan the sentence for keywords and underline each one. Each underlined keyword maps to exactly one arithmetic operator from the dictionary. Annotate each keyword with its operator so the structure of the future expression becomes visible. The annotation step turns the translation problem from intuitive guessing into mechanical lookup. Step 3. Assemble the expression using the operators in the order the keywords appear, paying special attention to the few keywords that flip the input order, less than, more than, subtracted from, and added to all reverse the natural left to right reading. Whenever you use one of these reversers, double-check the result by reading the algebraic expression back into English to confirm it says the same thing as the original sentence. The check takes 5 seconds and catches the most common translation error in beginning algebra, the order flip mistake on subtraction phrases. Building this check into your habit now will pay dividends across every later word problem chapter. Here is the first worked example. The sentence 5 more than twice a number is 17. Translate this sentence into an algebraic equation, then identify the variable, the operations, and the equal sign. 3 keywords are present more than twice and is. Each one maps to a specific operator from the dictionary. Step 1. Identify the unknown and assign a variable. The phrase "a number names the unknown quantity. Let n equal that number." Now every reference to a number in the sentence becomes n in the algebra. Step 2. Recognize each keyword and its operator. The word twice means multiplication by 2, so twice a number becomes 2 times n, written as 2n. The phrase more than means addition with a flip, so 5 more than the previous chunk becomes the previous chunk plus 5. The word is means equals, so the right side of the sentence becomes the right side of the equation. Step 3. Assemble the equation using the operators in the order the keywords appear. Twice a number gives 2n. 5 more than that gives 2n plus 5. The word is yields the equal sign, and the number 17 becomes the right side. The full equation reads 2n plus 5 equals 17. Step 4. Verify the translation by reading the equation back into English. 2n plus 5 equals 17 reads as 2 times the number plus 5 equals 17. Compare against the original 5 more than twice a number is 17. Same relationship, same numbers, same operations. Translation confirmed. So the translated equation is 2n plus 5 equals 17. The big lesson from this example is the disciplined 3-step workflow. Identify the variable first. Recognize the keyword operators next. Assemble the expression in keyword order while watching for the few keywords that flip input order. The verification read aloud at the end catches almost every translation mistake in roughly 5 seconds and is well worth the time. As a bonus check, you could now solve the equation subtract 5 from both sides to get 2n equals 12, then divide by 2 to get n equals 6. The translation step is what makes the solution possible at all, so investing in clean translation pays off many times over across every word problem in the rest of the course. Here is the second worked example. The sentence "the sum of 3 consecutive integers is 45. Translate this sentence into an algebraic equation. The challenge here is the phrase 3 consecutive integers, which requires expressing all 3 in terms of a single variable, so the entire equation has just one unknown. Step 1. Identify the unknown and choose a variable. Let n be the smallest of the 3 consecutive integers. Then, because the integers are consecutive, the next one is n plus 1, and the one after that is n plus 2. All 3 integers are now expressed as algebraic expressions in the single variable n, which is exactly what we need to write a solvable equation. Step 2. Recognize the keywords and their operators. The phrase "the sum of" means addition of all the listed items, so the sum of 3 consecutive integers becomes n plus the quantity n plus 1 plus the quantity n plus 2. The word is at the end means equals, and 45 becomes the right side of the equation. Step 3. Assemble the equation. The sum chunk reads n plus parentheses n plus 1 parentheses plus parentheses n plus 2 parentheses. Combine the like terms inside the 3n terms, add to 3n, and the constants 1 and 2 add to 3. So the left side simplifies to 3n plus 3, and the equation becomes 3n plus 3 equals 45. The combined step uses the like terms work from lesson 2 of this section. layering today's translation skill on top of the simplification skills you already built. Step 4. Verify the translation. 3n plus 3 equals 45 reads as 3 times a number plus 3 equals 45. The structure matches the original sentence. 3 consecutive integers means 3 copies of an unknown plus a small constant offset, summed equals 45, translation confirmed. So the translated equation is 3n plus 3 equals 45. The big lesson from this example is that translation often requires expressing several related unknowns in terms of a single variable. Consecutive integers, even integers, odd integers, ages of family members, costs of items in a budget bundle, all of these require parameterizing the unknowns relative to one another, so the final equation has just one variable to solve for. Choosing the parameterization wisely and writing the like-term simplification cleanly are the two craft moves that separate confident word problem solvers from confused ones. As a bonus check, you could solve the equation subtract 3 from both sides to get 3n equals 42, then divide by 3 to get n equals 14, so the three integers are 14, 15, and 16, which sum to 45 exactly. 3 mistakes that catch every algebra student during their first weeks of Word to Algebra translation. Each one is fixable with a small explicit habit applied on every problem. First mistake: translating less than and subtracted from in the wrong direction. A student reads 5 less than a number and writes 5 minus the variable, when the correct expression is the variable minus 5, because less than reverses the input order. Same trap with subtracted from 10. Subtracted from a number is the variable minus 10, not 10 minus the variable. The fix is to always read your translated expression aloud and confirm it says the same thing as the original sentence. The order error becomes audible immediately. Second mistake: misreading the word is as a subtraction or some other operation. A student reads x is 7 and writes xx minus 7 instead of x equals 7. The word is in algebra word problems almost always means equals, not subtract. The same goes for gives, yields, and results in, all of which are equal sign words in standard math English. Build a strong association between these verbs and the equal sign so the translation is automatic. Third mistake: naming two variables when the problem only requires one, or naming one variable when the problem requires two. Consecutive integers, ages of relatives, prices of bundled items all need to be parameterized in terms of one variable. Choose a base, write the rest as offsets from the base. Two variable problems like rates and mixtures need both variables explicitly. The choice between one and two variables depends on the structure of the problem, and parameterizing well is the most important translation craft skill in the course. Words to algebra translation is one of the most used soft skills in all of practical mathematics and engineering. Every applied problem starts as English and ends as algebra, and the translation step is what bridges the two worlds. 4 broad domains below. On standardized tests like the SAT, GRE, GMAT, and most state algebra exams, the math sections are dominated by word problems. The actual algebra in these problems is usually quite simple, but the translation step is where most students lose points. Students who have memorized the keyword dictionary and practiced the read aloud check can answer a typical word problem in under a minute, while students who guess at translations waste 2 or 3 minutes per problem and often arrive at wrong answers anyway. The dictionary is the single highest leverage memorization investment for these exams. In engineering and software requirements documents, every specification line translates into a mathematical constraint or inequality. The pump must move at least 300 liters per minute translates to a greater than or equal to inequality. The error rate must not exceed 2% translates to a less than or equal to inequality. The translation step is what allows the requirement to be checked automatically by a test or simulation. Engineers who can translate fluently move much faster on requirements work than those who cannot. In legal contracts, service level agreements, and financial documents, penalty clauses, refund formulas, escrow rules, and tax brackets are all written in English but specify precise mathematical relationships. Lawyers and accountants who can translate the English to algebra can spot ambiguities, errors, and gaming opportunities much faster than those who only read the English. The translation skill is in continuous use across these professions. Even in everyday life, recipes use translation: doubled, halved, per serving, total yield. Kitchen calculations, hardware store conversions, and budget planning all use the same keyword dictionary you are memorizing today. The skill scales from grade school word problems to billion-dollar contracts, and the dictionary stays the same throughout. 3 things to take with you from this lesson today. Words to algebra translation is the single highest leveraged soft skill in the entire algebra course because every word problem in algebra, geometry, calculus, statistics, physics, finance, and engineering starts with this exact translation step. First, translation has 2 halves: keyword recognition and word order reading. The keyword dictionary provides the operators, and the word order check ensures the operands appear on the correct sides of each operator. Both halves matter. Either one alone is not enough to translate reliably. Practice both together by reading every translated expression aloud and comparing to the original sentence as a built-in verification step. Second, memorize the keyword dictionary, the sum, plus, and more than mean addition, the difference, minus, and less than mean subtraction, the product, times and twice mean multiplication, the quotient, divided by, and per mean division. The word is along with equals, gives, yields, and results in all mean the equals sign. 15 or so entries total. Spend 10 minutes on flashcards and you will have the dictionary code for life. Third, the phrases less than and subtracted from reverse the natural left to right order on the page. 5 less than a number is the variable minus 5, not 5 minus the variable. Whenever a translation involves these phrases, double check by reading the algebraic expression back into English. If it says the same thing as the original sentence, the translation is correct. If it says something different, the order is flipped and you fix it immediately on the spot. Coming up next, the lesson called Translation Traps, where we collect the trickiest sentence patterns that fool almost every student on the first attempt and build a small library of templates that handle them automatically with very little thought. The combination of today's dictionary and tomorrow's trap library will let you translate almost any algebra word problem you encounter for the rest of this course and beyond.